Hello everyone, I'll be solving the February 2022 Chemistry Ace Level Paper 12. Just put time 1 hour 15 minutes. Alright, first analysis energy of potassium is 418 kJ per mole. Okay, so for first analysis energy, the factors are distance between the nucleus and the outer shell electrons, and the shielding effect, and the nuclear charge. So let's see, so if you look at the periodic table, you can see that strontium does have a charge larger than the K, but okay, yeah, that checks out. Okay, the outer electron SR atom experiences greater shielding. That's contradicting to the statement, so no. Outer electron SR atom experiences spin pair repulsion. That's still contradicting. SR atom is further from the nucleus than the outer electron, a K. Okay, and that's also contradicting, because all these three statements suggest that SR has a lower ionization energy. Okay, so it's gonna be A. Alright, second question. Mg2 plus, so 2 plus means it lost 2 electrons from the number of electrons you see on the in the periodic table, and you remove the 2 electrons from the outer shell, because if you go according to the off-bow rule, you're gonna fill the 3p, the 3d after the 4s. So sometimes you may remove from the 3d before the 4s, which is wrong. You have to remove from the 4s before the 3d. Okay, so let's see the periodic table, and Mg has an atomic number of 12, so it has 12 electrons in the atom. So after it loses 2, it's gonna have 10, but let's first do the normal atom. 1s2, 2s2, 2p6, and that adds up to 10. Then let's add 2 more, so it's gonna be 3s2. Now we're gonna remove these, so we're gonna have 2p6 as the last, and gonna be A. No, pretty simple. Okay. So we have the masses, and we can now make ratios. So X produces, okay, never mind, it's not empirical. So we're gonna write the reaction first. So X plus O2 releases CO2 and H2O, because it's had completely combusted. So in X is oxygen, so 4 grams of carbon dioxide, 1.63 grams of water. Okay, so now let's think of moles. Okay, so if this has, let's say, okay, let's see how many moles CO2. Okay, so if you go according to the triangle NMMR, so the M is 4 grams, and M is equal to N multiplied MR. 4 equal to number of moles multiplied by the MR, which is 12, plus 16 multiplied by 2. So N is 4 over 12 plus 16 multiplied by 2. That's damn, so we number 0.091 moles. So okay, fine, just go with that. Then H2O, same thing, 1.63 over the MR, which is 18. That's easy. It's 0.91 also. So the ratio is 1 to 1. The ratio is 1 to 1. That doesn't mean it's 1 and 1. It can be 2 and 2. So basically the ratios are the same. So if we have C and H that that will give you 1 to 1 ratios, this will not give you 1 to 1 ratios. This won't give 1 to 1 ratio. This will give you a 1 to 1 ratio actually. It's gonna be C. Because if you have CH, H2O, so you're gonna have half in front of the H2O, if that's what you're going about. You're gonna have CO2. And here, CO2, you're gonna have a 2 here, and then the H2O is gonna be 1, so they're not 1 to 1, so that's wrong, that's wrong. And here you're gonna have CO2, and then 2 here, and then the H2O, 2 here also. And you can't really simplify this more because you have an oxygen that's 1, so it's empirical, that checks out, and the ratios check out, and CH2O2, nah, CH2O2, why is it wrong? So let's see, CH2, so this is gonna be 1, this is 1, completely normal stuff. CH2O2 plus O2 makes CO2 plus H2O. Okay, 1 to 1. So here you have 3 oxygens. The oxygens there, kinda weird. Yeah, the oxygens don't balance, that's why. Okay, which molecule is the dipole moment 0? So CH3Cl, CH3Cl. No, they're not. It's not. I mean, tetrahedral is in fact a symmetrical shape, but the dipoles they don't cancel out. They don't all go in the opposite directions. So I'm gonna cancel this for now. CH2Cl2 still feels a bit weird. CCl4. Since all the chlorines are pulling towards each other, they will cancel each other out. So they have a overall 0 dipole. Each bond on its own is polar, but when you add them all together, since they're like in opposite directions and it's a symmetrical shape, it will be an overall a 0 dipole. Then Al2Cl6. So Al2Cl6 is a dimer structure made of AlCl3s held together by 2 dative bonds. Okay, so let's see. So that's correct. These 2 dative bonds are correct. It's not ionic, and no, it's not in between the ALs. This isn't a dative bond. This is a normal covalent bond, so that's wrong. Now we're just left with B, and B is the answer. Boiling points of some hydrogen halides are shown. Explanation for the trend in boiling point. Boiling point, hydrogen halides HCl to HI, so there's an increase. Okay, so the bond energies. So when you're talking about boiling points, you're not really talking about bond energies, the intramolecular. You're talking about the intermolecular forces of attraction. So this is wrong. Intermolecular forces of attraction. That's correct. Intermolecular hydrogen bonds. No, you don't have hydrogen bonds. Only HF has hydrogen bonds. Increase in the bond polarity. No, because the electronegativity decreases down the group. So this can't be real. This can't be true, you know. Let's be 7. Elements X, Y, and Z are in the first 2 pages of the periodic table. Okay, so they give us electronegativity. Substances exist with the formulae XZ, YZ, and Z2, which reports these in order of increasing melting point. So XZ is very polar. This has very strong like very strong intermolecular forces. So the highest melting point I'm gonna guess is xz is the highest. Oh no, that's yz. xz. And then yz is gonna follow after that, because it is better than no dipole at all. See, that was a relatively simple question. Equation for reaction 1 is shown. What is the correct expression for the enthalpy change of reaction 1? Okay, so reaction 1. So you have combustion of this and this. Okay, so it's gonna be 2 of whatever this is, so 2b, so anything that doesn't have 2b is wrong. And then since it's combustion and you have arrows pointing like this, you have this is the route that's the reaction is following. So these are going the same direction, so this is gonna be positive. These are going in opposite direction, so it's gonna be negative a minus 2b. And there's a rule: combustion means reactants minus products. So your reactant here is A, product here is B, A minus 2B. Nitrogen monoxide is an atmospheric pollutant that's formed inside car engines by an endothermic reaction between nitrogen and oxygen. Which diagram correctly represents the energy profile for this reaction? So it's endothermic, so these are wrong. Okay, so from the reactants onwards, this activation products, the reactants, correct, and the arrow's going down. Arrow has to be going down. No, should be arrows going up since it's endothermic, and the arrow goes from the reactants to the product, so it's A. Two half equations are shown. The equation for is shown. Which statements are correct? Okay, so let's. Two half equations are shown. The equation for the reaction between manganate 7 ions and sulfide ions is shown. Oh, okay, so we're gonna have to do like some balancing and stuff. 2e's, 3e's, multiplied by 2, multiplied by 3. So this is gonna be 6, gonna be 3, 3, 3, 6, cancel this. 2, 4, 6, cancel this. 2, 8. I think the OHs are gonna cancel out, so this is gonna cancel out. It's gonna be 2 OHs. H2, I'm not sure if they cancel out, but I think they will, so cancel this one. It's gonna be here. Okay, so we have x equal to z, u equal to x equal to z, u which is 2 equal to x which is the MnO2 which is 2 also, and then z OH it's 2 also. Yeah, that's correct. Manganese is reduced to oxidation state +4. Manganese here has an oxidation state of, so if we do, I'm gonna calculate -1 equal to x plus 4 multiplied by so -1 equal to x plus 4, x multiplied by -2. So we're gonna have the oxidation state of I mean, that's really something you have to memorize. I mean, you memorize it by practicing, but if you don't know, you can just do it. It's easy. Then here's gonna be +4 because 2 -2's, and then it says total of 0, so it's +4. So +4 to plus, oh, it's okay. To oxidation state +4, that's true. Sorry, I'm left-handed, that's why I did tick mark in the opposite direction. Sulfur is oxidized from oxidation state +4 to +6. Here it is +2. No, the fuck. It's plus. Oh, okay, cancel that shit out. Cause I said the F word. Okay. So here's gonna be. So that's gonna be -8, and it ends up with -2, so that's +6. And here's gonna be, that's a -6, and ends up with -2, so that's a +4. +4 to +6. A. Hydrogen peroxide decomposes to form water and oxygen. The reaction is catalyzed by bromide ions. Okay. So here, H2O2 is aqueous. Bromide ions are aqueous, so it's homogeneous. Same state. Homogeneous catalysts are catalysts that are in the same state as the reactant, but heterogeneous is a different state than the catalyst than the reactants. And in step 1, what's happening? Okay, so it's either C or D. Step 1, bromide ions are oxidized. Okay, so -1 to 0. Yes, that is +1, so that's an oxidation. Yep, it's correct. C. Well, let's also check D. Bromide ions are reduced. No. Okay, easy question. Hydrogen and iodine react to form hydrogen iodide in exothermic reaction. The equation is shown. 1 meter cube reaction vessel contains H2, A2 and HI gases at equilibrium. The temperature is changed such that the total pressure doubles. Okay. Temperature is, okay. Temperature is changed. And the only factor that affects Kp and Kc is temperature, so it will affect. So no change is wrong. Effect on Kp. Okay, so Kp is the partial pressure of Hi squared over the partial pressure of H2 and the partial pressure of I. So if we increase the temperature, so let's see the relation between pressure and temperature. Okay, so if we increase the temperature at a fixed volume, the pressure will indeed increase. So this is temperature and constant volume. Okay, so if you increase the temperature and the pressure increases also, here you have 2 moles, here you have 2 moles, so the pressure isn't really a factor here that we're caring about. The temperature is what we care about. This is exo, okay, my bad, it's written here exo and here's endo. So increasing temperature means that it will shift backwards, so this will decrease and this will increase, so the Kp decreases. It's A. Okay, I'm gonna butcher this name. Diethyl zinc, okay, no, never mind, is added to NaOH aqueous. 2 reactions occur. In these reactions, which compounds act as a boron-acid Lowry acid? So these are proton donors. Okay, so what donates a proton? In reaction 2, let's find reaction 2. It's gonna be definitely the H2O. And then here, what's donating a proton? So you're forming an OH minus ion and then an H plus ion, which goes to this, and the Zn, which is zinc, reacts with the OH, forming the, no, not the OH, no. So it's the H2O definitely, cause here you have the H is increasing, so it's like you're forming an OH and an H, and this H goes and this H goes again. You have an O left, it reacts with the zinc, forms this, and then the H's will react with the ethyl. It is kinda weird though, but just look at the hydrogens, which one's increasing and which one is decreasing. Okay, my Apple Pen died. Okay, so we're gonna take a break and then I'm gonna be back charging my pen. Okay, so I'm back, pen charged, everything. Okay, so we said reaction 2, it's the H2O that's giving the H plus. Here also is the H2O, so the answer is gonna be B. Which statement about atoms and molecules is correct? Molecular formula of a compound is the simplest whole number ratio of atoms. Okay, no. I don't even see. Okay, so that's not molecular formula, that's empirical formula, so A is wrong. 1 mole of any substance contains atoms. No. Because if it's a compound, then you're gonna have this much molecules, not atoms. You're gonna have to multiply the number of molecules by the number of atoms in a molecule. For example, CO2. If you have 1 mole of CO2, you have 6.0, okay, 6.6, okay, multiplied by 10 to the power of 23 molecules of CO2. So individual CO2 molecules, but then the number of atoms is gonna be that multiplied by 3, because each molecule has 3 atoms in it. So B is wrong. The relative atomic mass of an element is the ratio of the average mass of one atom of the element to the mass of an atom. What? Average mass of one atom? No. Of the isotopes. The relative formula mass of compounds is the sum of the individual atomic masses of all the atoms in the formula. That is correct. 14 is D. 15, okay. Boltzmann distribution for 1 mole of a gas temperature T is shown. 1 mole of the same gas is added at the gas remains at temperature T. Which dotted curve shows its distribution with the added gas? So the peak is gonna stay the same, everything is gonna stay the same, because the temperature is not changed. You're gonna have just more molecules having the same energies and everything, so it's A. Okay, 16. The reaction shown the concentrations of both X and Y are reduced to half of their original values whilst keeping the total volume of the solution constant. Simultaneously, temperature is increased from 298 to 348, which prediction is definitely true. Okay, so from 298 to 348, okay. Both X and Y reduced to half while keeping the total volume of the solution constant. A smaller proportion of collisions between particles of X and Y will be successful. I'm gonna put that on the side, because it doesn't feel completely true, like correct. It's not definitely true. The average kinetic energy of the particles in the will increase. Okay. The average kinetic energy of the particles of X and Y will increase. Okay, so let's see. Oh, it said temperature is increasing. Okay, so this is definitely wrong. My bad, I forgot to factor that in. The temperature is increasing. You have more successful collisions because more particles with energy over the activation. So you have more successful collisions. Okay, so A is definitely wrong. A is definitely correct. B, I mean, is definitely correct because average kinetic energy is the temperature. Rate of reaction will be unaffected. No, it will be affected because of the temperature. Frequency of collisions will have no, because the temperature increases greater than, it has a greater effect than decreasing the concentrations. So it's gonna be B. 17.